Okay, this question, a certain drug is being administered to a patient in the hospital at a constant rate RMG per minute. So the amount of the drug present in his body at time t is x. So in other words, the rate of change of drug being is RMG per minute. Alright. The loss, okay, but this is what enters the patient's body, and the drug is lost from the patient's body is proportional to the amount of drug present in his body. So equals to K, no, not equals to, whatever enters the patient's body minus whatever leave the patient's body. And in this case, the amount of drug, there's the rate at which the drug is lost from the patient's body is proportional to x. Therefore, k is the proportionality constant, and x, because it's losing from the body, that's why it's the negative, and r is the rate at which the drug is entered and administered into the patient. So this would form the differential equation. Then given the amount of drug in the patient remains constant at the instant when it is 1.5 RMG. That means the rate of change remains, if the drug in the patient remains constant, that means x remains constant when when the drug amount is 1.5 RMG. So but that means the rate of change of drug in the body is 0. That means it doesn't change, because it's a constant, dx dt would be equals to 0. So therefore this simply means that dx dt when the amount of drug in the body is 1.5 R is equals to 0. So that will lead to either 0 equals to R minus K times 1.5 R. These are X, right? 1.5 R is your X. So that will give me that will allow me to find K, right? K in terms of R. So K equals to this, I bring over, so positive K, then R divided by 1.5 R will give me 1 over 1.5. 1 over 3 over 2, so 1.5 is 3 over 2, so will come to third. Right, so that will be K, right? So then K will substitute back into this equation, and it will result in this equation dx dt equals to R minus 2/3 x, and that's how we got to this. This is how we show. Then if his body is initially free of drug, this sentence really means that x, the amount of drug in the body, is actually at time t equals to 0 is actually 0, because there's no drug in it at time initially means t equals to 0. Right, then we are asked to find x in terms of t. So we'll use, so first, before we have to find an equation in terms of x and t first. So we will do the integration, right? So we'll do integration by taking r minus 2/3 x, 1 over r minus 2/3 x dx. Alright, I'm just dividing this on both sides of the equation, so I got the 1 on the other side, and multiply the dt over, when it's a first derivative, you can treat this effectively like a fraction of dx divided by dt. So when we rearrange the algebra and then just put these two integral sign, This is the way I think of it. And then integrate. Now in this case, we just need to note that r is just a constant, so doesn't really matter that much. We just take 1 of 2/3 out of the equation, 1 divided by 2/3 out of the equation, and then we will get 1 over 3 over 2r, right, minus x dx. Okay, and this is just equals to 1 over 2/3 is 3 over 2, and then when we integrate in this, right, note, okay, actually I could put a minus so that I have a minus sign here. So the purpose of doing this is such that the numerator is the derivative of the denominator. That means when you differentiate the denominator, it gives you the numerator. When this is the case, we will just be ln the denominator. Right, this is the technique of integration. Alright, when the numerator is the derivative of the denominator, when you integrate, it will just be ln the denominator. Okay, so then this will be t plus c. Okay, it came from here. Right, when you integrate 1 with respect to t, you get t plus c, where c is an arbitrary constant. Okay, and from here we will use this formula. We will use this fact, this information that they give us to solve for our c. Okay, in terms of our so then t equals to, when t equals to 0, my x is 0, so I'll have 3 over 2r ln 3 over 2r multiplied by 3 over 2. Okay, and that will result in this, that okay, that, yeah, it's just this. Okay, so c is just this. Okay, then I will just substitute back into the equation. Or another way to do it, which is a neater way to do it, might be this. That means I will take 2/3 multiply over, so I have 2/3 t plus, now it doesn't matter what is c1 is just a constant. Actually c1 is just 2/3 multiplied to c, but it's a constant, we need to find it, so it really doesn't matter to define what is c at this point, or to write 2/3 c1, doesn't matter, it won't be useful. So we just ln 3 over 2r minus x. I'm showing you another way of doing, which is neater than what I've shown you just now. So this will be 3 over 2r minus x equals to e 2/3 t, right, plus c1, right. But we also know that by exponential rule, it's just ec1, right. Since ec1 is just a constant, we just replace it with a constant, we call it a, and we put it in front. So that's neater. Okay, and then we will just put it as this equation. We will rearrange it. We'll have, in terms of, so we get x equals to 3 over 2r minus ae 2/3 t, like this. Well, looks neater than just now. Then at this moment, then we apply the fact that t equals to 0, x equals to 0. Since t equals to 0 when x equals to 0, for 0 equals to 3 over 2r minus a e, 0 times 2/3 will be 0. So that means this implies that my e to the power of 0 is 1, so it's just a. So this implies that minus a bring over becomes a, so a equals to 3 over 2r. And so my general solution of the differential equation is x equals to 3 over 2r minus 3 over 2r e to third t. Okay, to make it simpler, I just factorize out the 3 over 2r 1 minus e to third t. Okay, so this will be the general solution. So when t approaches infinity, x approaches alpha. So let's see, when t approaches infinity, and this will be infinity, and I think somewhere I might have gotten it wrong somewhere here. So let's look back at the r minus 2/3. Did I get this wrong? So dx dt and 1.5r equals to 0. So 0 equals to r minus 2/3, or r minus kx. X is my 1.5r, so correct. So this would be k 1.r minus, so would be, this would become, divided by 1.5r, so 1 over 1.5 indeed is like 2/3. Okay, k equals to 2/3, so I have not gotten it wrong. This one is correct. Okay, so when I integrate this r minus 2/3 x, I bring it over and integrate it on both sides. Yes, this is t plus c, this is ln 1/3 minus 1, so this would become, if I put a negative sign outside, no, when I put, okay, so this would be negative 1, negative 2/3, so this would be, when I put a negative 2/3, so this will be negative, then this one will be 3 over 2 r minus x. Yeah, this is correct. Okay, so this is correct. So when the top is the differentiation of the bottom, we just ln 3 over 2 r minus x, 3 over 2. Oops, yep, I forgot one thing. There must be a minus sign over here. When I take 1 divided by 2/3, right, I forgot the minus sign over here. So I need to change this so that when I multiply minus 2/3 on both sides, there should be a negative sign here. Doesn't matter c1, because c1 is a constant, it could be positive or negative. So I just use c1 to represent a negative number now. So then negative 2/3, so there should be a negative sign here, right? When I bring the ln of, becomes exponential, there should be a negative 2/3 here. Then and a equals to EC1, doesn't change. A equals to EC1. Alright, and correct. Now everything is correct except for this, there should be a negative sign over here. 3 over 2 minus a e minus x. Then after that, 3 over 2 r minus a e0. Okay, it's still 0. When t equals to 0, it's still 0. Then minus, so a equals to 3 over 2r. So x equals to 3 over 2r minus 3 over 2r e minus 2/3. Alright, that's the, then I factorize out 3 over 2r, there should be a minus here as well. So then when t approaches infinity, what happens? E minus 2/3, negative, e negative infinity is just 0, so 1. So this will be 1 minus 0 is 1. So I will have the x approaches 3 over 2r. So what is the significance of these results? This tells us that That means when time approaches infinity, that means if you keep on administering the drug to the patient continuously, the amount of drug that will be present in the body will go to a constant at 1.5 milligram. So if you want to keep that level of drug in the patient, you should continuously apply the drug for infinity amount of time. Right? So if you calculate this wrongly, I don't know what happens to the patient, right? Yeah. So that's it for this question. Oops, I just add one point. If the drug is administered continuously to the patient for a very long time, the amount of drug in the body, in the patient's body, will stabilize at 3/2 mg. Okay, so that's it.